All right, so we're back looking at section 4.6, and remember we started off by discussing this concept of function notation, and so we were in the middle of example 3 when I decided that we should give this a break and move on to another video so we can get a little bit more time. So here we are with f of 1 plus 4. So basically what this says is figure out what the value of this function is at 1 and then add 4 to it. So I'm going to do that right now. So remember what I told you I like to do? I like to here's the function that we're dealing with. F right now is being defined as f of x is equal to 2 times x plus 5. And I told you I like to ignore the x and replace it and kind of leave it as an open parentheses. So now f of 1 is equal to 2 times 1 plus 5. So 2 times 1 plus 5, this thing is equal to 7. So now I'm going to replace f of 1 with 7, and I have 7 plus 4, and my final answer is 11. I hope that made sense to you. Let's go ahead and use that concept over here with something a little bit more complicated. So remember, we're still using that f of x is equal to 2 times x plus 5, right? And I said, well, I like to ignore the x, and then I like to replace the x. Let me make this a little bit bigger, maybe too big. I'm going to replace the x with what's going on in here. So now this doesn't just have an x in here, it has an x plus 3. And so wherever I have that blank, I'm going to put x plus 3. And so f of x plus 3 is equal to, well, I'm going to simplify this. This is 2 times x plus 3 plus 5. You guys know how to simplify. This is a little bit of distributive property, right? Don't like the song, I'm sorry. So 2x plus 6 plus 5, and we're going to join like terms together. Here, this is at 6 and 5. We get 11, and we get 2x plus 11. So the story is f of x plus 3 is equal to 2x plus 11. Not too bad, right? All right. So here we have a function that is a nonlinear function, which basically just means a little bit more complicated. But we're okay. We can handle it. We have a strategy. So here h of z is equal to z squared plus 3z minus 4. I know that seems weird, so let's use my path, my plan. H of blank is equal to blank squared plus 3 times blank minus 4. Notice I just put blanks in everywhere the z's were. And now I'm just going to plug in the negative 4 because we're asked to evaluate h of negative 4. So when I plug that negative 4 right in there, I get an expression that I can actually deal with, right? So negative 4 quantity squared means negative 4 times negative 4, which is a positive 16, plus 3 times negative 4, well, positive 3 times a negative 4 is a negative 12 minus 4. So this is basically 16 minus 12 minus 4, and I'm hoping that this makes sense to you. 16 minus 12 is 4, 4 minus 4 is 0, so the final answer here is 0. So when I am evaluating h of negative 4, I ultimately get 0. I'm going to make that a little bit smaller so I can keep on working. If you look over here, we've got the same function that we're working with, right? Same nonlinear function. H of blank equals blank squared plus 3 times blank minus 4. I'm going to put 5a in all of my blanks. And I'm going to just process this whole thing, right? I'm going to do the problem. So 5a times 5a is 25a squared. 3 times 5a is going to be a plus 15a minus 4. And as I look carefully, I realize I do not have any like terms. Therefore, I can't simplify it. It's got to stay just like this. And so I'm going to leave it like this. And this is my answer. H of 5a is equal to 25a squared plus 15a minus 4. Finally, this little thing, 2 times h of g. 2 times this whole thing, h of g. So remember my trick, right? I like to do h of blank is equal to blank squared plus 3 times blank minus 4. I'm going to put the g in there, but right now you're saying, but wait a minute, lady. Wait a minute, crazy lady. don't we have to multiply by 2? And I'm going to say yes. And if I got to multiply by 2 over here, I'm going to multiply by 2 over here. So it's a matter of making sure I make this thing look exactly the same. Now I'm going to use a little distributive property. I get 2g squared plus 2 times 3, 6g minus 8. And now I've calculated 2 times h of g. And finally, we've got a non-standard function notation. So sometimes on standardized tests, let me see, we don't have any more actual example problems. Sometimes on standardized tests, you'll see stuff like this, which really is kind of like function notation, but in a different way. And a lot of students will be like, what? I don't know what this is. Nobody ever showed me this arrow business. I don't know what this is. I don't know. Really, it is just you using your intuitive sense to figure out how to solve a problem. So they're going to define, they say, hey, this less than x greater than symbol, right, is basically anytime you see x in that, anytime you see a number in that situation, this is the thing you want to do to the number. Anytime you see a number like this, it means take that number, square it, subtract 4 times that number, then add 2. So when you get a problem like that, you just need to use the pattern and say, okay, well, if that's what you want me to do, whenever I see a number in that situation, I'm going to take that number and square it. Take away 4 times that number, right? And then add 2. See how this is a lot like that function notation we just worked on? So now I'm going to just simplify, evaluate this. 3 squared is 9 minus 4 times 3 is 12. Plus 2. 9 minus 12 is a negative 3. Plus 2 is going to give me a negative 1. And so the answer is negative 1, and I'm done. All right, guys, I hope that this was beneficial. Go over the function notation because it's one of those places where students just feel uncomfortable. And if you got it, high five yourself and keep it moving. Move on. I look forward to seeing you soon. Take care, and I'll talk to you later. Bye-bye.